Yeah, and for the exam, like I said, I'm just going to repeat this. It's going to be available starting from Wednesday morning all the way to Thursday before midnight. And then there are going to be 4 questions, 4 or 5 questions, and then you guys have up to 4 hours to complete and submit the exam. The format is going to be essentially the same. So you go ahead and, similar to the first exam, you're going to go ahead and open the start exam quiz, submit it, and then you'll see the submission tool on Google Courses. So you go ahead and download the Excel file. It's a macro enabled Excel file. You need to enable macros. It's going to create a random exam for you. You're going to go ahead and complete the exam and submit it within 4 hours on Google Courses using the same actually submission tool. So that's pretty much about what you guys need to do. And like I said, I'm going to send the detailed instructions on an email actually describing all the details you need to know for taking the exam on Tuesday night, or at least a few hours before the exam starts on Wednesday. All right, so that's about the exam. Let me know if you guys have any question about the exam. I thought actually today, since I gave you the review set and you already have the solution to that, the Excel solution, and also the video for the forecasting questions, because usually forecasting is a chapter that we recently finished it. And we didn't do a lot of practice on that. So hopefully that video is going to help you catch up with the chapter 8, with the 8th chapter, forecasting. I was actually hoping to spend our time mostly on the group activity too. I'm not going to solve it, but I just wanted to give you some general advice, like general guidelines on how to approach this question. And if you have any specific questions on practice 3 and 4, if there's any question that you guys wanted to ask, I posted the solution to practice 3. I also posted the grades to practice 3. I hope that you have no problem with that, with actually the questions, specifically with the answers to the questions on practice 3. But if you have any question, just let me know and we can review those. For practice 4, I'm going to post the solution on Wednesday morning, hopefully before the exam starts, right? All right. Is there any question on the review set that I've posted on Google Courses? Like I said, you already have the solution. Let's see, this is exam 2. This conceptual questions, the multiple choice questions, is just for yourself for practice. I'm not going to ask you to answer true, false, or multiple choice questions in the exam. It's going to be just Excel questions. So here, is there any question? Like I said, you already have this solution, the solved version of this exam. If I'm going to give you like a few seconds. If there's any question, just let me know. Otherwise, we move on to group activity. Forecasting questions, and then the regression question, I think the group activity and some of the practice questions that you have solved are pretty similar to this one. So I'm just gonna skip this unless you guys tell me that you had a problem with some part of this. And that was it, right?
This was the practice exam.
This was the practice exam, yes.
Okay, yeah.
Just gonna close this. Would assume you guys are good. I'll go directly to the group activity and we can discuss that. Okay, group activity 2. So there are 2 questions. Can I ask, like, what's the status of group activity 2 for your group? Have you guys started? Completed?
My group, we're just gonna work on it tomorrow.
Jacob, okay, no problem. So that's perfect timing. I'm just gonna
Yeah, my almost done with it. We just got like 2 more questions.
Christian, awesome, thank you. That's great. Like if you have done it and it's going to be basically quick reviews of the major points. Hopefully, if you haven't started or if you're just in the middle of that, that's going to be also good. Hopefully, if you guys have any question, perfect. You can just let me know. Same with your group, Lavina. So you can just let me know. So let's go ahead. Let's go ahead and go question by question. The first question from chapter 7. I'm sure you guys seeing this screen, right? And you see the question here. So in the first question, we have the DMV office question. Alexa, she's trying to explain the waiting time of people, clients in the DMV office. She actually collected a random, like information on a random sample of 550 customers, which we actually, I'm going to open the Excel file in a minute. But these are the questions that we want to answer. First, running the regression model to predict waiting time. So waiting time is going to be your dependent variable. Why? All the predictors provided in the file. So you're going to go ahead, there's nothing to select. You're going to go ahead and anything other than the waiting time, anything that has some informational value, you're going to take them and consider them as your independent variables. Whenever you see categorical variables, you're going to define them you're going to define appropriate dummy variables, indicator variables, or binary variables, 0, 1 type of variables, in order to convert them to numerical values, right? So because you can't have text or categorical or nominal variables in regression. So you have to convert them to numerical using dummy variables. And then, write down the resulting equation. So you just perform, run the regression, write down look at the coefficients, record the coefficients, and just write down the linear equation. Y is equal to intercept plus coefficient for the first variables, multiply the variable itself, first variable, plus coefficient of second variable times variable 2, and so on and so forth. What is the estimated impact of having appointment on the waiting time? So for estimated impact of a variable, you're going to need to look at the coefficient. Coefficient is going to tell you, coefficient of the variable having appointment is going to tell you what is the estimated impact on the dependent variable. If this impact is significant or not, you look at the p-value. If p-value is less than 5%, yes, it has a significant impact, which basically means that this impact is statistically different from 0, right? So to answer this question, the second bullet here, you just look at the coefficient that you get. If you get a positive coefficient for appointment, that means people who have appointment are waiting more. If you get a negative coefficient for appointment, for people who have appointment, that means waiting time for those people, for people who have appointment, is less. So I mean, logically, the second case should be true, but you can actually verify this using the coefficient and using the result of your regression. How much of the variation in waiting time does your model explain? Guys, I'm not gonna solve and give you the answer, but we can just go ahead, go over every single one of them and get the idea. For the third bullet, how much of the variation in waiting time does your model explain? How do we answer this question? I'm not looking for the
Isn't this the R squared
R,
or
Jacob, exactly. That's just the definition of R squared. R squared tells you the percentage of total variation in Y being here the waiting time, that this model, the model in your sample data explains. So that's really just the definition of R squared. So you just need to read R squared and just put it there, print it here. Check the multicollinearity and the necessary conditions for residuals and comment on the significance of predictors. So multicollinearity, this one is a correlation check. You need to check the correlation of all independent variables. If the correlation is, the absolute value of correlation is above 70%, that's the indication of multicollinearity. That's the indication of high correlation, 0.7, right? For necessary conditions, you just need to check the residuals. When you're running the regression, you want to check the residual plots, and you're going to check the necessary condition by looking at the residual plots. For residual plots to be fine, they need to be symmetrical around 0 at all points. And then they should actually, the variance should be constant. So when you go from left to right, you shouldn't see an increasing or decreasing variance. So you guys have, I mean, I'm sure we talked about this one, good and bad examples of residual plots. So you just need to check the residual plots and comment on that. And for the significance check, you need to check the p-values. If p-values are above 5%, that factor, that variable is not significant. If p-values are small, less than 5%, that specific variable, the corresponding variable to that p-value is significant. So you're looking always for significant variables. You're always looking for very, very small p-values, hopefully less than 5%. Before continuing, I would like to go ahead and open the data file here and just show you something before we move on.
Professor, I have a question.
Norma, yes.
So for practice 3, there was one of the questions where I got a 0 intercept and then the standard error came out as NA. Is that normal or did I do something wrong?
That's not really normal, no. You said p-value was 0?
No, the intercept, for the coefficient,
Yes.
the intercept was 0 and then the standard error was NA.
I can take a look at that.
Oh yeah, and the p-value was NA as well. So I think I did something wrong.
So when p-value is NA, that's the way Excel reports multicollinearity. So that's when Excel cannot calculate p-value, when it cannot calculate test statistic in order to calculate p-value. That's when usually this is caused by multicollinearity, high correlation in data set. But we can, like I said, we can take a look and see what was the cause of the problem.
Okay. Thank you.
Absolutely. Let me just go over these group activities questions, and then we go ahead and check the practice assignment.
Okay.
Perfect. Just for now, just focus on this one, on the group activity question from chapter 7. So one thing I wanted to show you here was how to run the regression. I'm not going to run the regression, or I'm not going to really comment on that. But waiting time, I said waiting time is what you want to predict. This is your dependent variable, and it says all explanatory variables are going to be considered as predictors of variance. Of course, the customer ID, the number of the customer or the order that the customer is seen or arrived to the DMV office doesn't do anything with the weight. I mean, that should be a general, or I think the order may have to do, but I think this is the customer ID, the like identification number assigned to different customers. So I would just drop this one. Anything other than this are going to be considered as independent variables. Some of these are quantitative, like age, number of working staff, number of waiting customers in the system. So these are quantitative, but the other ones, type of service, special need, time of the day, and walk-in or appointment, whether the person has appointment or not, these four are not quantitative. So let's just move age from here, just put it next to other numerical variable. So I'm cutting this from here, Control X. I just put it right here, insert cut cells. So that way I just move age from here to here. So now I have my three variables next to each other. Now for the other four, I need to convert them to numerical variables by using the dummy variables. So let's just focus on type of service first, and then you'll get the idea. So type of service, as you can see, there are three levels. There are three categories that this variable can take. The client can be a first-time client of a driver license, returning customer for driver license, or a customer for vehicle registration. Just to make it simple, three categories. So three categories. How many dummy variables do we need?
3.
So for a categorical, this is general rule. For a categorical variable with n levels, you always need n-1. n-1 dummy variables. Same thing applies to seasonal forecasting in the next chapter, chapter 8. If you have 4 seasons, you're going to use 3 dummy variables. If you have 12 seasons, you're going to use 11 dummy variables. So here we have 3 types. We're going to use 2 dummy variables. By 2 dummy variables, we can capture all of these 3. All right. So let's just go ahead and for type of service, I'm just going to add 2 columns right in front of it. And I'm going to call them. The first one is type of service, type, but this is a dummy variable. I'm going to define for DL first time, type of service. Next one, either driver license returning or the other one. Doesn't matter which 2 you pick, as long as they have approximately equal size, you can pick any of them. So you just go with 2 of them. Doesn't, like I said, doesn't matter which ones. Technically speaking, doesn't matter at all. Returning and first time. So whenever you see here, whenever the type of service is driver license first time, you're going to put 1, otherwise 0. Whenever the type of service is here for this column is driver license returning, you're going to put 1, otherwise 0. And whenever both of these guys are going to be 0, it has to be vehicle registration by definition, because type of service can only take 3 values. If it's not this value, if it's not this value, it has to be vehicle registration. So when both of these guys are 0, then vehicle registration case will, the vehicle registration will be the case. And if you add that, if you add a vehicle registration dummy variable, exactly what Norma just described. You will have a case of perfect collinearity, right? And what happens is that Excel will have problem finding the p-value. That's why you have to always go with n-1 dummy variable. So how do you write it? So you're going to say if the type of the service is equal to DL first time, and you want to make sure that the spelling is exactly the same here. Put 1, otherwise put 0. Value if true, 1. Value if false, 0. Whenever you see DL first time, you should see 1 in front of it, and otherwise 0. If type of service is if DL returning, put 1, otherwise put 0. Exactly. Whenever you see driver license returning, you should, this actually should return 1, otherwise 0. And whenever both of them are 0, that should be vehicle registration. And that's what I mean when I say you should be able to capture all of these 3 cases, returning, registration, and first time, with only 2 dummy variables. Because if this is 0, type of service has to be vehicle registration. There is no second option. It has to be vehicle registration. All right. So this is how we converted the type of the service to 2 numerical variables, to 2 dummy variables, right? Okay, so that's for this one. For special needs, it takes 2 values, yes and no. So how many dummy variables do I need for yes and no?
1.
One.
Just one, exactly. So when you have 2 levels, 2 categories, 2 minus 1, just 1. Special need, dummy. If this is yes, put 1, otherwise put 0. This one is now converted. Time of the day, it takes morning and afternoon. How many dummy variables do I need?
1.
1 again, exactly. So you pick either morning or afternoon. So I would pick,
Morning.
yeah, I would pick time morning if time is morning, put 1, otherwise put 0. So this one is converted now. So now this dark blue cells, or these cells that actually their headers is identified with dark blue, these are going to be my new variables that are going to go right into the regression analysis. Same thing with walk-in and appointment. It takes 2 values only. So you need 1 dummy variable for this one. And I would just put appointment dummy, or you can put type of appointment and then put appointment. If this is appointment, put 1, otherwise put 0. Something wrong. There's a T, yeah. Yeah, so whenever you have, when the person, actually the client has appointment, you should see 1 in front of it. All right, so that's always good to check. And then let's just highlight this one also in dark blue. Now, what you need to do, you need to make sure that all these variables, and let me also highlight these guys with dark blue. Now, all of these columns that are highlighted in dark blue, these are going to be your independent variables. And the column that is highlighted in yellow is going to be your void. So what you need to do before you run your regression, you're going to just make sure to move everything next to each other. So cut, insert, cut, insert, cut, Control X, insert, right click, insert. So now you see all of the independent variables are connected. It's like a connected rectangle that is going to go to your regression tool. Beautiful, right? So you can hide this side or just let it be. But yeah, so I would assume you guys already know how to do the rest. So you just put these guys as your X range into the regression, and this one as the Y range, and run the regression. And we just also address these questions. Is there any question before we move on to the next part? So for estimated impact of a variable, you're going to check the coefficient for the magnitude of impact, right? If it's significant or not, statistically speaking, you're going to need to check here. For this part, you're going to check the p-value. But for the impact, the size of the impact, you need to check the coefficient. Second part, now add the squared number of working staff as another predictor, run another model with all predictors, including the squared staff number. So you're gonna basically repeat everything except that you're gonna have a new variable. Christian, yes.
I was gonna ask, if it's not significant for the last one, do you want us to on our own then adjust the linear regression for it to cut out that value? Or do you only want us to do that if you ask for that?
I mean, you mean for the exam or for this one?
Just for the exam and for the exam.
For the exam, I would just do whatever is asked. So if you guys are asked to check the significance, yes, just check the p-values. Otherwise, if it says, let's say, run a model like this one, run a regression model to predict something, I would just take this one as part of this question. Run a regression model. So you just need to write down your regression model. And what I mean by regression model is going to be your linear equation. But everything else that comes after it, I would assume that you guys should be asked. I mean, you can still do it, and I appreciate it, but I mean, you can use your time for other things, right? So just do whatever you're asked.
Okay, thank you.
Sure. All right, so now add the squared number of working staff. So here, number of staff here. So you're gonna add another column. So it's gonna be staff squared, or number of staff squared. And that's gonna be simply number of staff squared. And then repeat the same thing. You're gonna, for part 2 of these questions, you're gonna run another regression. You're gonna call again the regression tool. And then this time you're gonna put everything, including this one, staff squared. So you're gonna include this one as well. Yeah. And then write down the resulting equation. So you just write down, look at the coefficients and write down the equation. What is the estimated impact of appointment time on appointment type on the waiting time? So you just check to see if type of appointment has any impact. How much of the variation in waiting time does the new model explain? So that's just, again, R squared of the new model. Check the multicollinearity, necessary condition. I don't expect a lot of these to change, like multicollinearity. For all other variables that you already calculated correlation, they're going to be the same. The only one is going to be the staff and staff squared. That one is going to definitely be a high correlation. Staff and staff squared, the one that you just added here. These two are going to be highly correlated. Let's just check correlation. %99 correlation, almost perfect, right? So the maximum correlation is 1, so it's almost there. So there is a almost perfect correlation between staff and staff squared. So multicollinearity exists, all right? So here, when it says check the multicollinearity, I don't know about the other variables, but between staff and staff squared, multicollinearity exists. Now, what's the problem with multicollinearity? Multicollinearity, if you get both of staff and staff squared, both of them insignificant, then that's the problem. When you have to check multicollinearity, when you would assume that multicollinearity exists. So this is correlation. Let me just write down what I meant. Correlation between staff and staff squared. If, go ahead.
So, for the test, how do we have to find the multicollinearity, whatever the word is, for like each predictor, independent variable?
Oh yes, you need to do it for all of them. I just did it for this one because I knew this one is going to be problematic, but for the other, let's just do that. For all of the independent variable, what you need to do for multicollinearity, you're going to select these independent variables only, these columns, right? Actually, you don't need to select them right now, but you need to go to correlation tool in data analysis tool pack. And here in the input range, you're going to select these independent columns. All right. So for me is G3 to O153 grouped by columns, labels in the first row, and then put the output, let's say here. So this is how you check multicollinearity. And when you do that, when you run the correlation, you should just flag the ones that are above, like the absolute value is above 0.7. So this is 0.2, 0.02, 0.03. This is 0.09. So these are small, these are small. This is a little large, but still not large enough to be worried about. And this is 11%, so not very large. This is 12%. So those are good. The only thing is this one, staff and staff squared, right? So multicollinearity exists. So it exists. Now, is it a problem? Is it problematic? You have to check the p-values. If both p-values, when I say both p-values, I mean p-value of staff and p-value of staff squared are greater than 5%. If both of them are less than 5%, that's okay. You can move on. If one of them is less than 5% and the other one is above 5%, what you need to do, you just remove the one that has a p-value of greater than 5%. If both of them are greater than 5%, their p-value, that can be something that may be caused by multicollinearity. That's the only thing that multicollinearity does. If you have perfect collinearity, you will get error, actually, NA sign in p-value. But if both of them are greater than 5%, the fact that regression is showing them as insignificant variables might be actually due to the multicollinearity. If both p-values are greater than 5%, or basically both variables insignificant, you need to, so this is what you need to do. You need to remove one at a time, one of these at a time, and check the p-values. When you do that, when you drop one of these variables and run the regression model again, if the p-value still stays above 5%, multicollinearity, even though it exists, it's not causing any problem. All right, so that's basically what you need to do.
Professor, can you explain how you came out with multicollinearity exists?
Yes, so if, yes, let me just say this. If both p-values are less than 5%, it's not an issue. It's not causing any issue. If both of them are above 5%, if just one of them okay, so this is the general rule, like simplified version of the general rule when it comes to multicollinearity. Okay, this, when I said multicollinearity exists, so that was just the definition of multicollinearity. We just said if multicollinearity, if you see high correlation, multicollinearity, the definition is this: high correlation between independent variables. And when I say high correlation, I mean correlation above absolute value of correlation above 0.7. So if you see one number, at least one of these numbers above the absolute value, above 0.7, that's you should just flag it. You should just mention this. This is there is high correlation here, which might be problematic. So multicollinearity exists because the correlation between staff and staff squared is almost 1. Now, does it cause any trouble? You need to check the p-values for staff and staff squared. If both p-values are less than 5%, even though multicollinearity exists, it's not causing absolutely no issue, right? If one of them is less than 5%, the other one is greater than 5%, just remove the one that is above 5% and run the model again. That way you get rid of the multi-collinearity effect. If both p-values are greater than 5%, it might be like having p-values that are large might be because of multi-collinearity. So you want to be careful. You're not going to remove both of these variables. You want to be a little bit cautious here. So you're going to drop them one at a time, one by one, and check the p-values. See if you drop one of them, monitor the impact on the p-value. See if the p-value goes down. If it goes down, it's an indication that there are some degrees of multi-collinearity affecting the p-values. All right, question? And then for residual plots, when you get the residual plots, you can actually have that slide open when you have good example of residual plots in chapter 7 and bad examples of residual plots, and then compare to those cases and see if it closer to the good example or bad example. That way you can actually also find the problem with the with your residual plots if any problem exists. All right, so let me go back here. Now remove all the non-significant variables. So when you run the regression, after you run the second regression, you check the p-values. You will have a regression table. I can actually run it now. I don't want to do it because it's just going to be it's your assignment. And I want to make sure that you guys are doing it. But anyhow, you just check the p-values. If you see a p-value greater than 5%, you're going to come here, for example, highlight them in gray or another color that shows you that these are non-significant. And you need to physically remove them. Let's say if type of DL driving, if type of appointment, driver license returning, for example, if this one is not significant, you're going to cut it from here and put it outside of your table. You remove it from your X range. Coming back here, which model would you prefer? For comparison between models, there is actually a video I want you to watch on YouTube. And for this one, you just want to check the adjusted R-squared and also the significance of the variables. So if you have a model that is the adjusted R-squared, the goodness of the fit is, let's say, the same, or roughly speaking, the same. But the model is much simpler than the other one. So you have, let's say, 5 out of 5 significant, whereas in the other one, you have 5 out of 10 significant with the same R-squared, with the same adjusted R-squared. You're going to always go with the simpler model. All right. What's your prediction for a person with this specific pieces of information? Once you have a good model, here you're going to pick the best model based on adjusted R-squared and based on the significance of variable. So you're going to use this equation to find an estimate for this person. If in your model you don't have age, you don't need to use 60. All right, so you just want to make sure that you're using only the information that is only, pieces of information that are relevant, are helping you, are significant in your model. Can you help her come up with other independent variables? Yeah, anything that you can think of that may affect the weighting of people in DMV office, other than the ones that we just mentioned, right? It might be layout, it might be the rain, snow, like weather outside. There might be a lot of other things that may affect waiting time of people.
Okay.
Yes.
if we don't have, so they gave us like, what is that, 3 variables right there? And if our model uses like 5 variables, what do we do for the other variables? Do we just plug in one, or like, how do we deal with that? I guess I'm asking if that makes sense.
Not sure if I understand. So you said if we have 3 variables and then what was 5?
So like, so we derive our equation, right?
Yes.
And each of our independent variables is multiplied by whatever value it gave us, and then like types of service, or the number it gave us times special needs. So if our model consists of variables,
You're talking about this one, right? The
Yes, yes.
definition. Okay, sorry. Yes, go ahead.
so let's say they gave us those variables and we go to plug them into our equation, but we still have an extra independent variable that has no value given to it. What do we do with that?
Just ignore that.
Just ignore it? Okay,
Just ignore it. Yeah, don't use it.
okay.
Just go with the model. Here, when you answer this part, which model would you prefer? So you're gonna go always with your preferred model. So this is my preferred model, and in this model, I just need to know 1, 2, 3, these 3 pieces of information. If I have extra information about this person, I don't care about it because it's not gonna actually help explain weighting of people based on based on your statistical analysis, you came to this conclusion, right? So if something is too much extra pieces of information, just ignore them. Any other question from this one before we move on? Jacob?
Yeah, so for the number 4, you would just plug in those numbers into the model equation?
Yes,
Okay, and then,
that's exactly what.
perfect.
Yes, and it's going to give you a number that's going to be your prediction for the
Yeah.
waiting time of that person.
Mhm.
Yeah. All right, guys, moving on. Next question, chapter 8. This is a pretty standard question, and it's very, very similar to the question that we did in class last week. So we're gonna do, first of all, here, doing a time series plot, that's just easy. Just select sales or whatever. Let me just open it. It's monthly sale. Yes, so it's sales information. You're gonna go ahead and select the sales column and then insert a line chart. That's gonna give you the time series plot for the pattern. You just need to be careful on whether you can actually identify any pattern in your data. So let's say here, insert line chart. If you see similar fluctuations from a year to another year, that should be your clue here that there is seasonality. If you see a constant increase from a year to another year, that's, I mean, you can always add a trend line. And if you have a straight line, not flat, as you can see here, it's slightly going up, right? From here, when you actually check the grid lines, you see it starts from the beginning and then it kind of taking off, right? There's a significant difference here. So it's going up, but the trend is not that huge, like the increase. But definitely there is a slight trend here. And also I would assume that you should expect some similar variations in data, very, very similar variations in data. So seasonality is there, trend is also there. And then do you consider moving average as an effective method for this one? So when do we use? No, yeah. Well, you don't have to really do this. It says, do you consider moving average? Probably not, because we just said in the previous part, we just said trend is there, seasonality is there, and moving average is not really a recommended method for those. Moving average is great when you have horizontal pattern. Data is randomly fluctuating around a constant mean. That's not the case here. Using dummy variables for seasonality effect, forecast sales for January toward December of the 5th year. So now seasonality effects, only for seasonality effects. So what you need to do, you need to come back here. So, like I said, similar to the in-class assignment, you can just go back and watch that. This one is actually, even though it's called month, it's really a period number. It's not month. So you need to add month yourself. And month is a number, the month number is a number between 11 and 12. Sorry, between 1 and 12. So you just need to do that and just repeat that for the next year. The month number in the next year, month number, month number. So this is like period numbers, 1 to 48. And you also need to do it if you want to forecast for the next year, right? So you don't have the information right here. You're going to highlight that. All right. So you're going to do that, and then you're going to create the, how many dummy variables do you need if you have 12 seasons, 12
11.
periods?
11.
Yes, in one cycle, 11. So you're going to go M1 or month 1 to month 11. Yeah, and then you're going to say if month number is 1, put 1, otherwise put 0. If month number is 2, put 1 here, otherwise put 0. If month number here is 11, put 1, otherwise put 0, and then you can drag it down. That way you'll get all the dummy variables that you need. And then you can run the regression for seasonality. Add a trend effect to your forecast model. So you have the dummy variables, you're gonna add the period number before. I can actually, it's always nicer if you, I think if you copy and paste, that would do, yeah. Or you can just cut and insert it here. Either way is fine. So these are in seasonal and trend. So these are gonna capture the seasonal effect or seasonality effect, and this one is going to capture the trend effect. So you're going to run another regression with these guys. Again, extremely similar to the in-class assignment that we did last Wednesday. So you can check that, and I'm sure there are other videos similar to this one. Which model is expected to give more accurate forecast? Use MSE for both techniques. So for this one, for seasonality and for seasonal and seasonal trend, especially if you guys are asked to do MSE, it's a little different the way Excel actually finds MSE. It's just actually divided by n-1. But we just took a simple average. We basically divided the sum by n. But you can use the MSE that the regression gives you. You can actually use this MSE because when you run it, I don't have it here, but when you run the regression, let me just run a random regression here and just want to show you. Let's say saves based on period. Labels. Here, MSE, this is MSE. You can use this for comparison purposes. When I say use MSE in this question, when you run, I mean, this is nothing. This is a hypothetical regression. Assume you run the two regression, one only with these 11 dummy variables, the other one with these 11 dummy variables plus period. When you have both models, both actually regression summary output, you can come here, read the MSEs. You don't have to calculate error squared and take the average of error squares for this specific. For other methods other than seasonal and trend, you need to calculate error squared and then take the average of error squared. But for this one, even though it's slightly different, it's slightly larger than the number that you would get if you go with the formula that you all know, taking the error squared and then average of error squared. It's going to give you a slightly lower number than this one, but that's okay. I mean, especially if you want to use it for comparison purposes, you always get the same result. Qualitatively speaking, you get the same result. So that's absolutely okay. All right, let me go back here. Assume that restaurant sales in January of the 5th year turns out to be the specific amount. What was your forecast? So you just need to check your forecast. How do you explain this error to the manager? So you forecasted something, the actual sales turned out to be different. How do you explain? There can be lots of causes that can actually make your forecast or the actual deviate from your forecast, or your forecast deviate from the actual, right? And there are always some unexpected factors, some factors that you didn't include in your regression model, some other things that are, I mean, in your model, you consider them as random factor, random fluctuations, but they're always there affecting your forecast and affecting the realization of actually sales in this case, and making deviation in your forecast eventually. All right,
Professor,
go ahead.
so for this specific question, when you get your regression equation, would you just plug in the period number
Yes,
and then that would
period and dummy variables for
and then yeah, okay.
yeah.
Wait, got you. Yeah, I got it.
Guys, here when I said add a trend effect to your forecasting model in part 3. So part 3, you did a forecasting model. You actually created a regression model with 11 dummy variables. Now in part 4, you're gonna add trend to those 11 dummy variables. So you're not gonna run just a trend forecast, right? It's gonna be trend plus 11 dummy variables. So you will have 12 variables in your regression. It's going to be a larger regression, not a very small regression.
This one's kind of off topic. No, it's still on topic, but let's just say we're calculating the MSE for like a moving average. So we have to incorporate the K value. And my only question is, when we calculate the MSE, are we only going up to the values that we have actual values for, and we're excluding the periods that involve forecasting?
Simply yes, yes, yes.
Okay.
Only the variables for which you have actual and forecasted values. Actual values of sales and forecasted values of sales. So you want to make sure that you have both of them. And that's the only way you can calculate error.
So would we, in the MSE equation, when we sum them up at the very top before we take the average, that sum, would that include the forecasted values too for MSE and the MAA in the other one?
What's the sum? In Excel, we just, when you have, let's say, error squares, you just take the average of them, average of the ones that you could find. Simple average.
Okay.
Yeah. All right. Okay, I'm just gonna move on, guys, to the practice assignment. So you just let me know if you have any question on practice 4. So time series and forecasting. I'll get to Norma's question, or maybe wait. Let's just go over this one real quick, and then I promise I'll be with you. Was there any question on practice 4 you guys needed help with? This is exactly like some of these, I'm sure I believe I solved them and I posted the video on Google Courses. So you just should have like question 23. I would assume you should have a video of that. And this one also is a seasonal. Yeah. And causal. So that causal and seasonal. So it's just a combination of these two. So, and it actually gives you all the instructions, what you need to do, like 8 dummy variables and a temperature. So you will have 9 variables in your regression. You know what? I'm gonna stop actually recording, and I'm just gonna spend the time that we have to go over your personal questions. I'm just gonna let you guys share your screen, and if you need help with anything.